Welcome to the Deep Dive. This time we're tackling a question you might not have even thought to ask. Are those charming old European buildings really tougher than modern American homes, especially when a hurricane hits? You've given us a fascinating mix of research papers, building codes, and even a reimagined fairy tale. Okay, let's unpack this.
What's fascinating here is the assumption that older automatically means better. We often romanticize historical construction, but survivorship bias plays a big role. We only see the buildings that survived, not the countless ones that crumbled.
Right, like that line in one source about how building materials other than wood often perform better in hurricanes.
Yeah.
Makes you wonder, what happened to all those wooden buildings in those same areas? Did they just not get built or...
Precisely. And even the surviving structures might have undergone significant repairs or modifications, so we're not comparing apples to apples.
Okay, so let's dive into the nitty-gritty of hurricane forces. We've got this research paper that breaks down wind pressure, storm surge, flooding, even flying debris.
The key takeaway here is that it's not just about brute strength, it's about engineered resilience. Modern building codes, especially in hurricane-prone regions like Florida, have become incredibly sophisticated.
Yeah, I was struck by how this source on Florida building code stresses the importance of connectors. It's like the Three Little Pigs story. The wolf can huff and puff all he wants, but if the house is tied together properly...
Exactly. Think of it like a car. You could have the strongest engine in the world, but if the chassis can't handle it, the whole thing falls apart.
So does this mean wood frame construction is inherently weaker? I mean, the second little pig in that reimagined story did build with wood.
Here's where it gets really interesting. Wood, especially engineered wood products like plywood and OSB, can be incredibly strong and resilient if it's designed and built to resist specific forces.
We've got this source from the Engineered Wood Association that talks about how plywood sheathing can make a house 2 to 3 times stronger against winds and earthquakes.
This highlights the crucial difference between materials and engineering. The Three Little Pigs analogy is apt. It's not just about what you build with, but how you build it.
So we're talking about the difference between a pile of lumber and a house built to withstand a hurricane.
Precisely. It's about understanding how wind forces act on a structure and then engineering the wood framing, the connections, and the sheathing to work together as a unified system.
Which brings us back to Florida. Building code, it's all about those specifics, right?
Absolutely. The code dictates everything from the types of nails and connectors to the spacing of framing members. It's all about creating a structure that can withstand those intense wind loads.
This is making me realize I've taken a lot about building for granted. I thought it was mostly about picking the right materials. Brick seems sturdy, but this whole engineering aspect is eye-opening.
It's often the unseen elements, those carefully engineered connections and reinforcements, that make all the difference in a hurricane.
So those charming European buildings with their centuries-old bricks.
Might not fare so well against a Florida hurricane, especially if they weren't designed with those specific wind forces in mind.
Okay, wow, this is blowing my mind. So what about something like the EF scale? I know it rates tornado strength, but is it relevant to hurricanes too?
It is, indirectly. While the enhanced Fujita scale is specifically designed to assess tornado damage, it highlights a crucial aspect of wind engineering, understanding how structures fail under extreme wind loads.
I've always been fascinated by how they use damage to estimate wind speed in tornadoes, almost like forensic meteorology.
Exactly. And one of our sources, a study on roof failures in wood frame houses during tornadoes, found that the EF scale might actually need some adjustments, particularly for hip roofs, which are common in hurricane-prone areas.
So even the way we assess wind damage is constantly evolving.
Absolutely. As we learn more about wind forces and how different building components and designs perform, our methods for assessing damage and designing for resilience continue to evolve.
This is making me rethink everything I thought I knew about building. Those old world, they don't build them like they used to. Assumptions are out the window.
It's not about romanticizing the past, but about applying modern engineering and building science to create structures that can withstand the challenges of today's world, and particularly the increasing intensity of hurricanes.
It's fascinating to think that something as seemingly simple as a roof can have such a complex relationship with wind.
It is. It really is. It's a great example of how even small design details can make a huge difference in hurricane resistance. A gable roof with its 2 sloping sides might seem inherently stronger, right? But those large flat surfaces can act like sails in high winds, creating significant uplift.
Uplift. So like the roof actually trying to lift off the house.
Exactly. And that's where hip roofs, with their four sloping sides, have an advantage. You see, that pyramid-like shape offers less surface area for the wind to push against, reducing uplift and making them inherently more resistant to hurricane force winds.
It's making me think about all those houses you see after a hurricane, completely roofless, and wondering what kind of roofs they had.
It's a common sight, unfortunately. And it really highlights why understanding these design nuances is so important for anyone building or buying a home in a hurricane-prone area.
Okay, so we've talked a lot about the importance of engineering for wind loads, but hurricanes are more than just wind, right? What about flooding and storm surge? We can't engineer our way out of rising water, can we?
You're absolutely right. Water is a huge factor, especially in coastal areas. And while we can't control the ocean, we can certainly design and build homes to better withstand its fury.
One of our sources mentioned elevating homes on stilts or piles as a key strategy for mitigating flood risks.
Elevation is incredibly effective, especially in storm surge zones. By lifting the living space above the anticipated flood level, you're essentially creating a buffer zone between the house and the rising water.
But we touched on this earlier. Elevating a house also increases wind loads. So is it a trade-off? Higher risk of wind damage for less risk of flooding.
It's a balance, but not necessarily a trade-off. When you elevate a house, you're essentially changing its relationship with the wind. Instead of hitting a solid wall close to the ground, the wind now has more space to flow underneath, which can actually reduce some wind loads. However, it also means those higher wind speeds are impacting the structure.
So you're not just elevating the house, you're elevating the complexity of the engineering.
Precisely. This is where working with experienced professionals who understand these nuances is critical. A qualified structural engineer can analyze the specific site conditions, calculate the wind loads at different elevations, and design appropriate bracing and reinforcement to ensure that an elevated home is both flood resistant and wind resistant.
Okay, so we're talking about elevating not just the house, but the quality of the engineering and construction that goes into it.
Mhm.
It's not a DIY project.
Absolutely not. Building in hurricane-prone areas requires a deep understanding of building science, engineering principles, and local building codes. It's a specialized field.
Speaking of which, I'm curious about those other materials mentioned in one of our sources. It mentions that while wood is common, some building materials perform better in hurricanes, but also that they often need more reinforcement to handle being elevated. It feels like we're back to the idea that there are no easy answers.
Exactly. It's not as simple as saying material X is better than material Y for hurricane resistance. It depends on a variety of factors, including cost, availability, local building practices, and the specific design of the house.
So it's all interconnected. Material choice influencing engineering needs, which influences whether it's even viable to begin with.
It's a holistic equation. And while new materials and technologies are constantly emerging, it's crucial to remember that even the most innovative material won't perform well if it's not part of a well-engineered system.
This is really making me rethink that whole, they don't build them like they used to.
Mm.
And it seems like, yeah, maybe they didn't, and we've learned a lot of since then.
It's a testament to the power of human ingenuity and our ability to adapt to challenging environments. We're constantly learning from past experiences, refining our building practices, and developing new technologies to create structures that are safer and more resilient.
So we're not just building houses, we're building on generations of knowledge and innovation.
Exactly. And as our understanding of wind forces, flood dynamics, and material science continues to evolve, we can expect to see even more innovative and resilient building solutions in the future.
All right, so we've talked a lot about the what and the why of hurricane-resistant construction, but for those of us who might be terrified of a DIY project gone wrong, what does this all actually look like in practice?
Yeah.
Okay, so let's bring this down to earth for those of us living in hurricane country or thinking about it. What does all this engineering know-how actually look like in a house?
That's a great question because it's easy to get lost in the weeds of building science. But when it comes to hurricane resistance, it's the practical applications that really matter.
So what are we talking about here? Give me the hurricane-resistant highlights reel.
Well, first and foremost, it starts with the building codes. We've talked about Florida's code as a good example because it's specifically designed for hurricane-prone areas.
Right, and it sounds like those codes cover everything from the foundation to the roof.
They really do. For instance, in hurricane zones, you'll often see homes built on elevated foundations, either on stilts or with a raised crawl space.
So that's that flood and surge protection we were talking about.
Exactly. It creates that crucial separation between the living space and potential floodwaters. But then the code also dictates how those elevator foundations need to be braced and anchored to resist wind loads.
It's all connected literally.
Precisely. And then we move up to the framing of the house itself. Here's where those hurricane straps and tie downs come into play.
Those metal connectors that hold everything together.
Exactly. They're strategically placed throughout the structure to create that continuous load path we discussed, tying the roof to the walls to the foundation, everything working together to resist those intense forces.
So it's like the hurricane has to fight the entire house, not just one part of it.
That's the idea. And then we get to the roof itself, which, as we've discussed, is particularly vulnerable to wind damage.
Especially uplift. That image of a roof peeling off in a hurricane is seared into my brain.
Well, in hurricane-prone areas, you'll often see hip roofs, which, as we talked about, are inherently more resistant to uplift because of their shape.
That pyramid design, right?
Yep.
Less surface area for the wind to grab onto.
Exactly. But even with a hip roof, the way it's sheathed and attached is critical. That's where plywood or OSB sheathing comes in, creating a strong diaphragm that helps resist racking and uplift.
So it's like giving the roof a suit of armor against the wind.
That's a great way to put it. And we can't forget about windows and doors, which are also major points of vulnerability in a hurricane.
Right. Those are like the weak points in a fortress.
Exactly. And that's why impact-resistant windows and doors are becoming increasingly common in hurricane-prone areas.
They're designed to withstand flying debris, right?
Exactly. They have multiple layers of glass, often with a layer of impact-resistant film sandwiched in between to prevent shattering.
So even if something does hit them, they're less likely to break and let the storm inside.
Precisely. It's all about creating multiple lines of defense to protect the home and its occupants.
This is making me realize that a hurricane-resistant house isn't just about looking strong. It's about a whole system of hidden details and reinforcements working together.
Exactly. And that's why it's so important to work with experienced professionals who understand these nuances: builders, architects, structural engineers, people who know how to translate those building codes and engineering principles into a safe and resilient home.
Okay, so for those of us who aren't building a new home, but maybe buying an older one in a hurricane-prone area, what should we be looking for?
That's a great question, because there are definitely things you can look for and things you can ask about to assess a home's hurricane readiness.
Give us the checklist.
First, it's always a good idea to get a wind mitigation inspection. This is a specialized inspection that specifically evaluates a home's ability to withstand wind forces.
So it's like a hurricane checkup for your house.
Exactly. An inspector who's certified in wind mitigation will look at things like the roof shape and attachment, the condition of hurricane straps and tie downs, the type of windows and doors, and the overall structural integrity of the house.
So they're looking for those hidden details that we might not even know to look for.
Exactly. And they'll provide a report that outlines any potential weaknesses and recommendations for improvements.
That's incredibly helpful, especially if you're new to hurricane country.
Absolutely. And even if you're not buying or selling a home, it's a good idea to familiarize yourself with the basic principles of hurricane-resistant construction and to look for opportunities to improve your own home's resilience.
So it's about being proactive and informed, not just hoping for the best.
Precisely. Because when it comes to hurricanes, a little bit of knowledge and preparation can go a long way.
So as we wrap up this deep dive into the world of hurricane-resistant construction, I'm struck by how much we've learned about engineering, innovation, and the ever-evolving relationship between humans and the natural world.
It's a reminder that while we can't control the weather, we can certainly learn to live with it and to create homes that can withstand its challenges.
And it's a testament to human ingenuity that we continue to develop new and better ways to build back stronger after every storm.
Absolutely. We're always learning, always adapting, always striving to create a safer and more resilient future. And that's a journey worth taking, one hurricane-resistant home at a time.
Well said. And on that note, we'll leave you to explore these ideas further. Thanks for joining us on this deep dive into the fascinating world of hurricane-resistant construction.